Today we're going to talk about Intro to Inequalities. Pretty simple, just a review initially of something that you should already know. So let's go ahead and get started. Basically, with inequality signs, you have four different types at this point. In inequality, you have a less than sign, less than or equal to sign, you have a greater than sign, and a greater than or equal to sign. Normally when we solve equations, we end up solving equations and we find one single answer. When we're dealing with an inequality, we're talking about several different answers. Several answers that will meet one specific requirement. Okay, so let's go ahead and look at these down here at the left. So if I see this one right here, x is less than, so that's what that means, x is less than. Okay, the small end is pointing towards the x. I know when I was a little kid, they may still teach it like this: Pac-Man eats the greater end, or the alligator eats the bigger end. You know, you want more meat or whatever. So in this case, the pointed end, or that small end, is pointing to the x, so I know the x is less than. And this is going to tell you something else too. Not only is it going to tell you less than, but it's also going to have a shade to the left. And we're going to talk more about that in just a minute. Okay, this down here is a mistake on my screen, but on your notes they should be fine. Let's change that. I'm going to mark that out. We're going to change that to x is less than or equal to. So this means, let me use a different color so we don't get confused. So this means less than or equal to. Okay, now in this case here, you still have the little end pointing towards the x, which is why you get the less than part. The equal to part is this little line underneath the inequality sign. That is half of an equal sign. So that's how you can remember that. That's a little indicator to you that that means it's also equal to. So one note I want to add here is that we're going to still shade to the left. But this time we're going to have a closed circle. I did not mention that in the previous example. And again, I apologize for my handwriting. I'm trying to write really small on this. But we will talk about this open. On the other one, the top one, is an open circle. Okay? And we'll talk more about the shading and the open and closed circle as we go. Okay, over here, now you have the big end eating the x, okay, or the big end going towards the x. You see that, Mariah? Okay? In this case, you now have greater than. Okay? And if the less than is shaded to the left, where do you think the greater than is going to be shaded to? Very good, Mariah. To the right. And this one also will have an open circle. And again, we'll talk more about that in just a moment. Okay, we need to change this one, not to x cubed, but to x is greater than or equal to. Okay, so in this case, it's still greater than. The sign is still the same, but now we have the little indicator, that line underneath the greater than sign. So that's also or equal to. So it's greater than or equal to. Again, we're going to shade to the right. And this time we're going to have a closed circle. Okay? So the little line underneath the inequality sign should give us two indications. One is that it's equal to, and one, we're going to have a closed circle, because both of the ones with the lines underneath it have closed circles. Okay, so those are the little indicators that we're going to get from that line underneath there. All right, so let's go ahead and put this into action so that you can actually see what we're talking about. Okay, when we have a single variable inequalities, we want to graph that on a number line. Okay, we're going to graph that on a number line, not a Cartesian plane or a coordinate grid, but instead just on a simple number line. We will eventually get to graphing on a Cartesian plane. We're sticking with the simple stuff, and we're just going to graph on a number line. So let's go ahead and graph the following on a number line. Okay, so now we have x is what? 10. Mariah? Very good. X is less than 10. Less than or equal to 10, excuse me. We have that little indicator sign that tells us it's equal to, and then of course it's less than. So how do we graph this? Well, the way I teach my students to graph is I simply just draw one line there, one number, and I'm going to make that a 10. And then I'm going to put a circle there. I'm going to put a circle on that 10. And then, do I want it to be closed or open? Well, if it's equal to, we have the little indicator sign, okay? If it's equal to, that means we're going to have a closed circle. Closed means that I'm simply going to color it in. Okay, so there's a closed circle. And then I'm going to shade which direction? Hopefully you went back into your notes and you see I'm going to shade to the left. So I'm going to shade this way right here. Okay? Now, let me give you a quick hint. If your variable is on the left side, as it is in this number one example, then your inequality sign, I'm going to make it a little bit bigger, is going to point the direction that we're going to go. So here's the x on the left side, right? Here's the x on the left side. This is my inequality sign right here. Now it's going to point me in the direction I'm going to go. So you notice how that matches? But that only works on the left side if the variable's on the left side. If the variable's on the right side, it doesn't work. You would have to do the opposite. Okay? Alright, let's look at another one. I'm going to use a black pen just to show you what we do when we have the same color, because you guys will be using pencils. You won't be using colored pencils. So in this case, I have 200 is less than x. Okay, 200 is less than x. I can do one of two things here. I can rewrite this. And if I rewrite this, I would say x is, if I read it from right to left backwards, x is greater than 200, right? Greater than 200. I can rewrite that. But the one thing I know for sure is because I have 200, I'm going to go ahead and put 200 on my number line. So there's 200. If I don't want to rewrite this, let's say I don't want to rewrite this, or I forget the trick that I just told you about the arrow pointing. When you read this, you can say 200 is less than x, or x is greater than 200. You can still read it backwards from in terms of x. So if x, the unknown number, is greater than 200, look at my 200. What numbers on a number line are going to be greater than 200? Is it this way? What number is this over here? Yeah, right, it could be 201. And then over here might be 199. Okay, so if I'm looking for numbers, because where my x is, I'm looking for numbers that are greater than 200, then what I'm going to do is I'm going to draw my arrow going to the numbers greater than 200. Okay, now notice how it's hard to see with the black marker, black pen. In fact, let me go back one step. What kind of circle am I going to have? Yeah, I'm going to have an open circle because there's no indicator that tells me I need to close it because it's not equal to, it's just greater. And then if I can't see my writing, what I can do is I'm going to make another arrow like this. I didn't draw an actual line, I just put the arrow so I can see that I'm going that direction, but really this is what I want, right? So x is greater than 200. Now let me explain that shading one more time, okay? When you shade something, that means you're including that in the solution. So going back to number 1 over here, if x is less than or equal to 10, that means 10 is an answer choice. Okay, so that means 10 works, 11 works, and so on and so forth. But over here, my 200 is less than x, okay, 200 is not an answer choice. Any number up to 200 is an answer choice, but 200 does not count. So that means 199.99999, okay, I'm sorry, 200.99999, that works, but 200 does not. That's why we have to put it there still. Okay, you don't want to leave that 200 out, only because the very next number, we're talking about tiny fraction, the very next number indicates to you that it is included. Okay, so let's move on. We're going to disregard this section down here on the bottom because I just don't like it. Alright, so let's move on to our next example. Okay, here now we're getting a little more complicated, and it's not overly difficult, but we are getting a little more complicated. We have 5x plus 6 is less than -4. When you solve an inequality, you solve it exactly like you would solve an equation. Okay, so I'm going to write that here at the bottom. Solve exactly like an equation. Now, there's one trick, though, one caveat to that. If you divide by a negative, if you multiply or divide by a negative, if you multiply or divide by a negative, I've got to spell negative, right? If you multiply or divide by a negative, and again, across the sign, you flip the sign. Okay, that might seem complicated, but we'll go ahead and put that into action here in just a second. So the first thing we want to do is go ahead and solve our inequality. I'm going to go ahead and draw the river like we're used to. And what I'm going to do is I'm going to go ahead and get x by itself like normal. So I'm going to subtract 6 from both sides. Okay, that's going to cancel those 6's out. That's going to leave me with 5x is equal to -10. Sorry, not equal to, right? Is less than -10. Okay? And then I'm going to divide both sides by 5. Now notice, I'm dividing by a positive number, so our little second caveat does not apply here. So then I'm going to end up with x is less than -2. Okay? Put that on my answer line. And now let's graph it. So when I graph this, first thing I want to do is go ahead and put down -2 on my number line. Okay? Is it going to be a closed or open circle? Yeah, there's no line underneath the inequality sign to indicate to you that it's going to be closed. It's going to be an open circle. Is our variable on the left side? It is. Which way is our inequality sign pointing? It's pointing to the left. Therefore, our arrow goes to the left. Again, another way to look at it is, and you really want to connect those, another way to look at it is, where are the numbers that are less than -2 on your number line? -3, -3, -4, and so on. All those numbers are less than -2. Okay? Let's go in here and let's solve another one. This time, we have 7 is less than or equal to x plus 16. Let's go ahead and draw the river. I want to get x by itself, so I'm going to subtract 16 from both sides. Okay, 7 minus 16 is -9, is less than or equal to x. Okay, so here we go. We have the answer being -9 is less than or equal to x. If you don't like that and you like the little shortcut that we used, you can rewrite this, but when you rewrite this, make sure that everything points the same direction. So x is greater than or equal to -9, right? I rewrote this, but I still have the small end pointing to the -9 and the open end pointing to the x. Okay, nothing changed there. Okay, let's go ahead and graph this. First thing I want to do is drop down my -9 on the number line. Do I want a closed or open circle? Yeah, I want a closed circle because it's equal to. Okay, if I use this one up here, arrow points me the direction. X is greater than -9, it's going to the right. Greater than goes to the right. My arrow points the direction. Okay, where are the numbers greater than -9? Yeah, -8 and so on, right? Great job, Mariah. All right, let's look at our next one. Now we have to translate, solve, and graph the following inequalities. So we're adding more to it. So it says 7 is, okay, so 7 is, as we translate this, we say 7, whoops, let me go back to that one. 7 is, so equals, I'm sorry, not equals because we're dealing with inequalities, right? So 7 is less than, so 7, jump pages again. 7 is less than 3, okay, less than 2 times a number. So 2 times a number, that's 2 times a number. Here, let me do it this way. I'll make it easier for you. Let's just write down everything that we have. So 7 is less than, so less than 3 less than, so that's -3, but less than is a switch here. Now that's not an inequality, that's a switch word. 2 times a number, so 2x, right? So 2 times is 2 times a number x, right? But now we have to use the switch word to switch those around. So our inequality becomes 7 is less than 2x minus 3. Okay? So now we want to solve that. So if I solve that, I'm going to go ahead and draw my river. Get everything away from the x. So I'm going to add 3 to both sides. That's going to cancel. Okay, that leaves me with 10 is less than 2x. Divide both sides by 2. And 5 is less than x. So our answer is 5 is less than x, or we can rewrite it as x is greater than 5. So x is greater than 5. Okay? When I graph this, I want to drop down my 5. Okay, what kind of sign? I mean, do I have an open or closed circle? Well, my sign indicates I have an open circle because it's not equal to. The arrow points the way, so I'm going to shade it to the right. Okay, very good. I'm gonna set up 6 for you, but I'm gonna let you solve that on your own. So let's set that up together. Okay, we have 11 more than a number. Okay, so 11 more than a number. So that means more than is a switch word. So plus 11, right? A number, x, divided by 5. Okay, so all of this divided by 5 is at most 18. What does at most mean? Okay, at most means that it cannot be greater than 18. So essentially this needs to be less than 18. Okay, so let's put all that together in our inequality, and we end up with x plus 11 divided by 5 is less than 18. Okay, so I'm going to give you a second on your own to solve that. Go ahead and pause the video for a second, solve that one on your own, and then check your answer. Okay, Mariah, did you get x is less than 79? Okay, hopefully you got x is less than 79. If I want to graph this, I'm going to set up a number line real quick. If I want to graph this, just pretend like this is the number line. You should have one on your sheet already. Okay. First thing I want to do is drop down my 79. My X is on the left side, so that's good. Okay, do I want to open or close circle? That's right, it's not equal to, so I want to open circle. And since my X is on the left side, my arrow points the way. That means I'm going this direction here. Okay. All right, any questions, please feel free to ask me in tutoring or in class. Alrighty. All right, last example. We'll try to run through this one quickly. It's just a word problem, but I want to make sure you have it because these tend to be the more difficult ones. All right, this is Gary weighs 170 pounds. Okay. He is loading a freight elevator with identical 65-pound boxes. That's important information. The elevator can carry no more than, that's going to be our inequality, 2,000 pounds. If Gary rides up with the boxes, so he's going to ride up, right? How many boxes can be loaded on the elevator? So if we want to set this inequality up, how are we going to do it? Well, we need to add, right, Gary's weight. So let's kind of write this out in words. We need to add Gary's weight plus boxes, right? And it has to be less than, because no more than, you don't want more than 2,000 pounds. It's got to be less than 2,000 pounds. Okay? So if Gary's weight is 170 pounds, we can fill that in and put 170 plus. We don't know how many boxes. That's what we're going to solve. But we do know how much each box weighs, right? Each box weighs 65 pounds times X, right? That's how many boxes that we're going to need. It's got to be less than 2,000. So there's our inequality. Let's go ahead and set the river up, and we can solve that very quickly. Okay? I want to get X by itself, so I'm going to subtract 170 from both sides. Okay, that's going to cancel out my 170. It's going to leave me with 65. X is less than. So 2,000 minus 170 leaves you 1,830. Divide both sides by 65. And X is less, has to be less than 28.2. All right, so really, if I'm answering a word problem, he can only have, you can't have 0.2 of a box, right? So the most boxes that he can have would be 28 boxes. All right, hopefully everybody got that same answer. If you have any questions, again, please feel free to let me know, and we will talk more about this tomorrow in class. All right, you guys have a great rest of your weekend.